Most people would say that fruits and vegetables are a great source of vitamins and minerals, but just because a food has something in it does not mean your body's absorbing it. In this video, I'm going to explain why the vitamins and minerals in certain plant foods are not biologically available, aka bioavailable, absorbed properly in the body, in comparison to animal foods, which have the same vitamins in much more available forms to our body. So this video is going to debunk the nutrient density of plant foods and focus on the high vitamin aspects of animal foods. And it's also going to be a very important point to talk about on a zero-carb carnivore diet, because people sell the diet as, oh, I feel so good on it. It removed all the inflammation because meat doesn't cause inflammation. And, you know, how is that a better selling point than these animal foods are literally the highest vitamin foods you can eat and they will make you the healthiest version of yourself possible? To me, it seems like a bunch of closed-minded people, or at least people that don't want to explore other aspects of this diet, don't understand that this is like a red flashing light in how to sell this diet and the importance of human health in general. It's like the zero carb or carnivore people who eat only muscle meat are so close yet so far from an optimal diet. So this is also focusing on that aspect. And I'm going to talk about the plant and animal forms of vitamin D, vitamin A, vitamin K, omega-3 fatty acids, and minerals. So I guess we'll talk about vitamin D first, because you know, vitamin D should be obtained from the sun, and there's two forms. The plant form is vitamin D2, the animal form is vitamin D3. The plant form, you guys could do your own research on it, D2. Plants produce it. There's some supplements made from it that cause questionable effects in humans. Vitamin D2 is not for us. Vitamin D3 is in certain animal foods, high quality, especially wild-caught fish, and we get it primarily from the sun. And the reason I'm bringing up vitamin D3 is because it can be obtained from food, although it not usually is, and there is a plant form and an animal form. And in this case, the bioavailability of the animal form is very apparent, and it's what we should 100% be using. It's very black and white, unlike some other vitamins, at least black and white to someone taking a quick look at it. So the next vitamin is vitamin A, and beta-carotene can be labeled as vitamin A on packaging and in plant foods, and that's not true, because beta-carotene has to be converted to vitamin A. And depending on the food, the rates can be anywhere from 30-to-1 to 100-to-1. So the conversion rates are fairly poor. Although there are man-made foods like yellow rice and spirulina that have slightly better conversion rates, there are various precursors that are needed, such as fats, and some people can't even convert beta-carotene to vitamin A. So the plant form of vitamin A, beta-carotene, it's not vitamin A, it's beta-carotene, it's different. It has questionable conversion rates and might not be converted at all. So we can get that in animal foods, and vitamin A is known for being in liver. It's in high amounts in any quality animal food, because just like vitamin K, the vitamin A content of a food depends on the quality of the grass the animal is on. The grass has a high carotenoid and vitamin K content. The animal can convert it to vitamin A and vitamin K2. Vitamin A is also the most important vitamin for healing skin. It's involved in healing any tissue in the body, from your pimples to a cut on your body to you recovering from a hangover and your liver's repairing itself. Vitamin A is used in every metabolic process in the body for repairing tissue. Vitamin K2, which I just mentioned, is mainly known for calcium metabolism, and there's still a lot of research being done on it, but it's definitely important. As with all the fat-soluble vitamins are, it's just involved in metabolic processes associated with other fat-soluble vitamins. And it's the thing about all these fat-soluble vitamins is, in ideal amounts in nature, they are all present in the food in certain ratios that allow your body to perform optimal metabolic processes. So you guys can do research on vitamin K2 and any of these vitamins. I'm going to put research in the comments. I'll talk about that later. And then omega-3s. So omega-3 has a very low conversion rate from ALA to EPA and DHA, and I've did a whole separate video on flax seeds, but basically the human body cannot convert ALA to DHA, and although people think it can, there has never been a study in males that has shown rising blood levels of DHA from consuming ALA. So alpha-linoleic acid being the omega-3 form in nuts, seeds, etc. So to basically sell omega-3s, you cannot get them from plant foods. There are some algae supplements you can use, but there's a whole bunch of misguided information on the bioavailability of omega-3s from plant foods. Not to mention how inflammatory a lot of those seeds and nuts are when consumed in large amounts. And the final thing to mention is minerals such as calcium, magnesium, and like people think spinach is high in calcium, but all these plant foods have oxalates, phytic acid, and spinach specifically has oxalates. And what oxalates do, and in the form of calcium oxalate, magnesium oxalate, they bind to the mineral. So oxalates bound to calcium, take them out of the body. And if you consume a meal that has oxalates in it, it doesn't matter if milk has calcium in it and spinach has calcium in it, the oxalates from the spinach will absorb the calcium from the milk as well. So most vegetables that people think are super high in minerals, and most plants and most grains, either have oxalates or phytic acid that binds to minerals and takes them out of the body. And in some cases, the mineral amount is slightly higher than the oxalate amount, but these foods are very inflammatory, and it's a no-brainer not to be consuming them after you do your research. And again, guys, I will put the studies in the comments. I have most of them on most of the topics I'm talking about. I touched on how vitamin A is in high-quality animal foods depending on the quality of pasture. I also said the same thing about vitamin K2, and the same thing about omega-3 fatty acids. Omega-3s are much higher in grass-fed products and pasture-raised products than in grain-fed products. So in order for you to get optimal amounts of these vitamins, you not only need to be consuming animal foods, you need to be consuming higher quality animal foods, and more specifically, in some cases, organ meats as well. So I think I've done a pretty good job of summing up that the form of these vitamins in plant foods is not available, and that there's various negative things in these plant foods that either prevent absorption or they're just not bioavailable to the body. Our digestive system is not equipped to digest them. Ruminant animals have much different digestive systems, and they can ferment, and they have different bacteria that can absorb these nutrients from plant foods. Humans don't have that. So I guess one last thing to touch on is to sum up the importance of these vitamins, and I'll do that by saying one thing. Whenever people say, "Frank, you look so healthy," why do you look like, how'd you get like that? What's your workout routine? Blah, blah, blah. I attribute every aspect of health in my diet to my understanding of nutrition and just basically these vitamins. And I know there's a lot of nuances to go along with that and a lot more explanation to do, but I think this video is a good first step in that direction, and I think it's just so important for debunking myths about various aspects of animal foods and plant foods. And I guess one final thing to touch on, although it's not really relevant to this video, I don't know how relevant it is. There is vitamin C in liver. I don't know if vitamin C is worth mentioning in regards to bioavailability, because it didn't really fit into this video, because vitamin C in plant foods is bioavailable just as it is in animal foods. So it's worth mentioning, but it's not really a topic of discussion because it's a water-soluble vitamin. But I guess that's it, guys. Thank you for watching. Let me know if I missed anything. I'm referring back to my notes here that I wrote down myself just to make sure. But I will focus more on, guys, let me know what aspects of this you want me to explain, go further in depth. But all my research I have is going to be in the comments. I'm probably missing like a dozen studies, to be honest, that I haven't saved. So if you guys have any, please let me know, and I'll edit the comments and put them in.